Hey everybody, it's Kevin from 3D Printed Props. In today's video, we're going to be looking at the 3-in-1 3D printer, laser cutter and engraver, and CNC machine. That's right, the Snapmaker A250. So this is the Snapmaker A250. It's the smaller model. So if you're looking at 3D printing, you're looking at a work bed space of 160 by 160 by 145. But I have to say, how this thing is built, it is incredibly sturdy and stable. Now, yes, it is over-designed for a 3D printer. The rails are very beefy. It is just solid aluminum, everything, amazing quality. Why it's over-designed for a 3D printer is because it's also a laser cutter engraver and a CNC machine, and it needs that strength and that stability for the CNC part. But everything else benefits from it, especially the 3D printing. So let's take a look at this. This is one of the models in their software, Lubin, which we'll be taking a look at. And it is crazy smooth. It's probably one of the cleanest prints I've ever gotten. And that's due to the fact that this machine is so solid and so firmly built. For these other things, especially the CNC, that one needs it the most, more than the laser. Incredibly smooth prints. I did this with Lubin, which is, or Luban, with their slicer. But then I also did this little guy here, this little dude statue you can get over on my website, 3dprintedprops.com, the file. And I did this in Prusa because I wanted to use the tree supports. You could use both. And I have to say, both of these are probably two of the cleanest prints I've ever gotten. The funny thing is I probably don't plan on keeping this as a 3D printer set up all the time, only because I've got so many other 3D printers. But this is making me wonder, I probably should use these for things I need to be super clean, because these are crazy clean. Now let's go ahead and take a look at how you get it ready for 3D printing and what you need to do. The assembly of this thing is super easy. If you want to see a complete assembly, you can stick around to the end, and I'm going to be putting it all together there. Really quick, if we take a look at how I've got this set up, I got it with the enclosure, and just so you know, Snapmaker sent me everything here. They sent me the printer, they sent me the enclosure. This is going to be an honest review. You're going to hear things I liked about it and things I don't like about it. I'm not getting paid for the review or anything. I don't get paid for any of the reviews I do. But it sent me the enclosure, which is great. So then 3D printing, I'll finally be able to test out some ABS prints, because I've really never printed ABS because I don't have an enclosure. Now I do. They also, of course, sent the unit and that. Now, what you might see over this shoulder here is the Hepa filter. I use some of my resin printings, venting into those. So the cool thing about the enclosure is, let's say a word about that first before we look at the 3D printing, is that it comes with, of course, LEDs, which is great, and an exhaust fan and the tubing. So I've run that tube since, I'm doing all this work here in the basement. It's hard for me to get to windows to vent to. I vent into that. Now, is it perfect? No. When you're doing laser cutting and it's burning in the plastic, it's burning into wood, there's some smoke. The fan does a really good job of venting that out. Do I still get some of the smell? Of course. The enclosure isn't hermetically sealed, so some smoke's going to get out, but I was really impressed at how well the fan sucked that in. I've got a smoke detector down here, and it never went off. And the smoke detector is right above me pretty much, never went off. So, it did do a really good job. And my wife didn't complain about the odor, and if she isn't smelling anything, then trust me, there isn't anything to smell. So that's how I've got that hooked up. If you're curious about any of the things I used like that, the Hepa filter, links are below. So let's go ahead and take a look at the 3D printer aspect, then we're going to look at the laser, and then lastly, the CNC. Go ahead and put the 3D printing head on, and again, it looks really clean. I plugged it in up top and into the controller area, and here is the bed. So it's a heated bed, of course, and it's got a magnetic removable, sort of like a Build-Tech, nice surface. But of course, what we need to do is now put all these screws in, and you're gonna have to do this every time you change a surface. It's a little bit of a pain, but you know, it has to be done, and you probably won't be switching things out on a, you know, daily basis. You'll probably be using one for a little while and then switching out. But for at least the smaller version, it was pretty easy to do. That, of course, magnetically snaps on, and we need to put the filament holder on, and look at how clean that looks. Heavy duty, shiny, amazing, and it screws right into the back. Now, if you end up getting an enclosure, you'll actually have to take that off and put it in the enclosure. So now I actually am just setting up the Snapmaker. I just turned it on. I'm doing my Wi-Fi, getting it ready, and then I am getting started. Now the first thing it's going to do is calibrate the bed. It automatically knows that the 3D printer head is on, and it's just going to go through all the steps to calibrate. And of course it doesn't happen this fast. This is through the magic of video. It's zipping right through there and getting it ready to do our first print. It homes it, and then of course we need to do, by moving the Z offset a little bit, just to fine tune it, and super easy. Leveling this thing took no time. Then we're going to go ahead and put the filament in, hit the little button, and feed it down through. Of course, it's not going to go all the way because we haven't heated it. Now here's that dude statue that I actually sent to the printer. All our controls right here. We could do whatever we want. We're just going to hit start, and it's going to go ahead and start printing. Now let's take a look at how we set files up to print them on the printer. Okay, so Snapmaker uses its own proprietary slicer and piece of software. Now you can use others, but I'm going to go ahead and just use theirs. So you go to their website, you go to software, and it is Snapmaker Luban or Luban. And we're just going to download that. And of course you could do it for any version. It's got Windows, Mac, all that kind of stuff. We're going to download it, install it, and then I'm going to show you how to set up our first 3D print. Okay, so when you first run the software, Luban, you get the configuration wizard. So I'm just going to go ahead and set that up. And let's see, 3D printing, single intrusion, laser module. I'm actually going to be setting that up for the, we'll do that later. I'll set it for the 1600 now. And then we'll change that later. I'm sure we can. We hit complete, and now we got a little interface here. So we can go ahead and we can say, do we want to do 3D printing? Do we want to do laser, CNC, or workspace? Now I want to connect this to the network so I can see the printer. So I'm going to go to the workspace, and I'm going to do Wi-Fi and confirm the Wi-Fi connection request with the touchscreen. Now, I will be pausing the video and going downstairs where the printer is to do this. Here we are in the interface, and it looks like a pretty clean slicer. We've got, you know, some nice presets here if you've never 3D printed before. Normal print, fast print, smooth, strong, and precise. Our settings we can do here. We can go more settings. So it seems like it's got quite, you know, it looks like a nice clean slicer. And let's go ahead and find a file and get this sucker ready to print. I just went back to the home area where they've got some files already set up for us to do. It's sort of like if you get your USB stick with a printer, same thing here. So let's go ahead and do this spiral vase. And it's going to go ahead and, I'm assuming, drop it, yep, on the build plate. We can look at our settings over here. Let's set this to, let's set it to fine. I'm curious what it'll be. Medium speed, so it's fine is 0.12, 40 millimeters a second. You know, let's do it fast. Medium, that's fine. I think all these look good. Skirt, brim, let's actually just do a brim. We don't need a skirt. And we're gonna hit generate G-code. It's all set. So if we click on export, we see we can export the G-code. That's gonna export it right to a file. And if we click load G-code to workspace, that's what we want. It puts it over into, you know, the workspace area where it is connected over Wi-Fi to the printer. So, you know, right now it's telling us that the not what the nozzle temp is. This is for the job, and it's going to require 6 hours. And once we hit start job, we then say send to device, and it's going to send it to the device. Now, if you do this, then you go ahead and you go down to the touch screen where your printer is, and you print it that way. You can start printing it there. But You could have also just said start from workspace and it would start it here. So I'm going to go ahead and I'm going to click start on Lubin, and it will go ahead and start the print. And what it's going to do is it's going to start raising the temperature. So if we look down here, we can see in the lower left-hand corner that the nozzle temp hasn't moved yet, but the actual temp of the bed has gone up a degree. And we're just going to have to wait until obviously everything heats up and we start printing. Target is 105, target is 70, and now we are printing via a Wi-Fi connection. I've never done that before, so that's pretty neat to not have to be running up and down the stairs with USB sticks. My printers are all in the basement, my office is upstairs, so this is kind of neat. I'm still going to go downstairs and check on it, obviously, but there we go. We've started our first print. Really super easy interface for this. And I did want to show you really quickly that the other statue was actually set up in Prusa. I didn't have to do it in Lubin if I didn't want. I set it up here, exported it onto the USB, brought it down, connected it to the printer, and printed it up. So again, the 3D printer aspect, super solid, really, really clean prints. Yes, it is a little bit of a pain. You're going to see next when you want to switch from machine to machine, at least on the model I have, there's a lot of screws you got to undo. Since it's a smaller bed, there's not too many and it's really not that big a deal. I use one of these little electric screwdrivers and it takes care of everything really, really quick. Now, the laser cutter engraver was the thing I was really super excited for. There's been a bunch of times doing cosplay when I wanted to maybe cut my own sort of, plexiglass eyes out and put in here, or other little pieces. Now, it won't cut clear plexiglass. Those you need like a CO2 laser, but black, solid plexi and things like that, it can cut and it does it very well. It was a little bit of a learning curve for me. Again, I haven't used a laser cutter before, but I have to tell you, the on-screen instructions and the book walked me through it step by step, and I was able to cut my first go. The software is pretty good. If you want to do some of your fancier type things, I'll show you in a second, you're really going to need to maybe use like Illustrator or some equivalent of Illustrator to separate drawings and things you might get online, or create your own. But other than that, it's a tight software and it sends it down to the printer. It does everything it needs to do. So to test out the laser, I really just stuck with wood for the 1600 milliwatt laser. I figured the 10 watt could do it easily, so I just focused on that. And I had a difficult time figuring out how to actually do the cutout, like you can see here, the cutout one. And then I realized I was going to have to use a different piece of software like Illustrator or something like that, which we'll show in the video, to be able to create that. Now, maybe you can do that in Lubin, and I'm just not used to it, and I was being impatient. But you can see how the engraving was really kind of neat, how it just sort of burned that in there. These are little JSONs. I bought these files on Etsy, for $1, just to do some testing with some fun things. And I really got a kick out of doing that. And then I figured out how to do the cutting. And again, we'll look at that in a minute. But then I wanted to jump right up to the 10 watt laser. So for example, it took 2 passes to cut this out of this thin piece of balsa wood or basswood, whatever they call it. I'm sure the 10 watt would have done it no problem. Now, why do I think that? I'll show you. So here is a black piece of plexi that they gave you. They also give you that piece of basswood. On this side here, I printed this and I used the 10 watt, or I'm sorry, I keep saying 10 watt, the 1600 milliwatt laser. And I did 3 passes to do the cutout. And as you can see, it did not cut it out. It did not even, well, it's kind of, you can sort of see air light through some of the pieces here, but for the most part, it's in there and it's not coming out. It did the engraving really nice. It looks really kind of cool there. Then I just shrunk it down because I was trying to save plastic, and I put the 10 watt laser on 1 pass, and it cut through there no problem. And it made this neat little Jason carrying a knife. and it did the laser cutting really fine. It did the engraving part of it really neat. I was really super excited how smooth this came out. I can really see some uses for this in the future. Now, then I wanted to get a little fancier and do something a little bit bigger, and I printed out this Batman. Again, this was just a graphic I found. I tweaked it in Illustrator to sort of separate the shapes so that I could make one shape do the cutting and another shape I wanted to reverse and have the Batman carved in. Now this is with the 10-watt laser. Again, one pass, super clean, smooth and easy. And then the actual engraving part was done only at 70%. So it wasn't even a full 100. In the testing that I found, the 10-watt laser, 100% for cutting, but for any type of engraving or burning in the details and things like that, you're really going to want to experiment. If this thing was a little bit thinner, it would have probably burned right through it at 70. So I probably could have cut this thing down actually to about 40%, maybe 30%. I've heard of some people using the 10 watt to do engraving from 10 to 40%. So I'm going to be playing with those and then keeping track of them, writing it down, and then putting it in a spreadsheet. But this thing is so cool. Again, for cosplay, I can just see some different things I can do with these things to really make shapes or pieces, parts for things that I don't want to 3D print, and I want to have this really clean, super polished look. Because I mean, the back of this thing, you would think you bought this. Even the front, it looks so neat. And I'm just getting used to the burning in part. I know there's a way to make it not look so liney, but again, I'm just, this is the second thing I cut with that 10 watt. And the Jason piece of wood one was the first thing I cut right out of the box. So that was really, really neat. So I'm going to be playing with these a lot more and just cutting stuff out. Now the neat thing is they give you a couple pieces of plastic. They get 3mm plastic. They give you a couple pieces of basswood. When you get the 10 watt laser, that's sold separately. They even give you a little piece of anodized aluminum because a 10 watt laser will engrave into aluminum. So I haven't done that yet, but that's going to be for another video. I'm really excited about that. Now that we've looked at this laser printer, the prints, let's take a look at how I sort of set it up to do laser cutting and laser printing. Not a lot of video for that because the enclosure has to be closed. I didn't want the lens being damaged by the laser or anything. So, but let's take a look. So we have to prepare the unit for laser printing. So we put down the bed that's used for laser printing, and it's these slatted pieces of metal that let airflow through to prevent fires. Make sure you have fire protection when you're getting this ready to print. You never know when something like that can happen. Now here are the lasers. You can see the difference between the 16 milliwatt and the 10. Much bigger on the 10. The enclosure is pretty neat though. It has controls right on it. And here is some of the video of the laser working. You can't see it a lot, but let's see how we got the files ready to print on it. Okay, so I brought this little guy in, and I worked on a little bit in Illustrator earlier, and you'll see what I mean. But you first bring it in, and the thing you want it to be engraved, you set to either black and white or halftone or grayscale or vector. And then I imported in this sort of line drawing around the figure that I separated out of the original one in Illustrator, and I set that to vector because I just want it to be a clean line. So that is going to be our cutting line. And this is what we got to do. We got to set these tool paths. So the first one we're going to set is for the cutting. So I've got it set to a preset of cutting 3mm plexi. I label it cut. It only has to do one pass because it's the 10 watt laser. I move this over a little bit so I can get at the next, the graphic underneath it. There are probably better ways to do it, but this was working fine for me, so I went ahead and did it this way. I'm going to create another tool path, and this one isn't cutting, it is going to be engraving, so I chose the bass engraving. I didn't see a plexi engraving, so I use this. I set the power down to 50%. Again, I probably could have set it down to probably 20% because it burned it in so well. I hit save. I labeled them so I knew which one is which, and it's really ready to go now. You can see which one's going to cut and which one's going to engrave. We hit export, and there we go. It's ready to sort of send to our workspace like we did with 3D printing. We hit cancel on the preview. We connect to our printer. And then what I want to make sure I'm going to do too is I'm going to rename this because I've been sending a lot of prints to it and they're all named the same. So this will help me out. I then go ahead and connect to the Wi-Fi and hit send to printer. If you'd like to see more videos using the laser on the channel, let me know in the description below. Again, right now, at the time of this video, this printer is on sale. This printer, CNC and laser, is on sale. You can hit the links below. It is an affiliate link. If you click on it, I do get a little bit of cash, which I'll use to buy more plexi, resin, filament, all that kind of stuff. So lastly, we're going to take a look at the CNC machine. And this is why this thing is built like it is. A CNC machine is a router bit pretty much that is lowered and spins like a router or like a drill, and then is moved across material and goes a little bit lower, and cuts the whole time. That puts an incredible amount of strain on a machine, on the bit, on everything. And that is why this machine is built the way it is. And again, the 3D printer just benefits from how solid it is. And what I did was I just printed out, not printed, I'm so used to saying printed, I cut out a little phone stand that I haven't put it together, but here it is. It's a little phone stand, these pieces that you can sort of hold your phone up on. It was cut out of this piece of plexi, and it took about 20 minutes. This is, what is this, 3 mil plexi. It took 26 minutes to cut this out. It's a while, but it is so clean and so sharp. Again, if this is something you needed for a project or needed for a cosplay, you know, you can't beat how clean this thing looks. Really, really super impressed. Made a mess. You can see here it has just got plexiglass dust everywhere. This is a great thing for the enclosure to have, so you're not getting this dust everywhere, you know, sawdust or plexiglass dust. And the CNC process was just as simple. I screwed the head on, I connected it to the control box, I put down the bed you needed for that. The only difference is you've got to use these clamps, and they are beautiful, but you want to make sure that the clamps don't go outside the work area so they don't get caught up on any of the rails. You can see it's just cutting these thin passes so it doesn't like break the spindle to cut out this really, really smooth piece of work here. And you can see the tabs that hold it into place are so thin they just pop right out. Now again, the instructions right on the screen, right on the touch screen, walked me through everything. I did this print one shot, never having used this machine before. Okay, so let's go over my takeaways for this machine, and let's look at the pros and the cons. Okay, so let's look at pros first. Pros. This machine does an incredible amount of things. You got 3D printing, you got laser cutting and engraving, you got a CNC that does cutting and engraving. That's incredible. If you have a small space, this thing is going to fit on your desktop, it's going to fit in your work area, and you can swap the heads out and the bases out to do what you need. So you don't need a huge amount of space to do a lot of different things with this unit. Number two, the thing is just built incredibly well. I'm pretty sure they said, okay, we need to build a really sturdy CNC machine, and then looked at what they would need for the 3D printing and everything else, because the CNC machine really needed the most strength, and everything else benefits from it. I've said it before. Those 3D prints are that clean because there is no wiggle room in any part of that machine, so you get these super, super crisp prints. 3 would be ease of use. I've never used a laser cutter before. I plugged the laser module in, I turned on the screen, and it said, do this, I did it. It said, do that, I did it. I did this and that. It walked me through 3 steps. I hit start, and it did it. The software is a little bit of a learning curve on that end, but if the actual machine and the cutting, super easy. I could not believe just how even the CNC machine, it just walked me through the steps and cut it out. I was just like, okay, boom, 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 next, next, next. start, and it made the print. So ease of use is really high up there. Okay, so let's take a look at the cons. Now, con number one might be price for some people. The unit is fairly pricey. It is actually, at the time of this video, going to be on sale. So take a look at the links below. They are affiliate links. If you click on them, I get a little bit of money and I buy more stuff. Like I buy more resin. Now I'm going to be buying more plexiglass to be able to cut. But it's a little bit of a pricey unit, and a lot of the add-ons are, you know, things you've got to pick up. You've got to buy yourself. So like the 10-watt laser doesn't come with it. In my estimation, it really should, just because you can't cut a ton of stuff, and you can't do a ton of stuff with that 16 milliwatt. But then again, that would just raise the price. Now, number two, at first I saw this as a plus, and I thought it was neat, but there's too many boxes. Having everything in its own box and then wrapped in plastic, and then that having a plastic cap on it, there's so much waste. Yes, they're cardboard boxes and pieces of plastic, so they're recyclable, but it got to the point that it was just ridiculous. For example, like the enclosure, I mean, I lost track of how many boxes and how many pieces of cardboard and how many pieces of plastic and how many caps and this and that I was dealing with. They were all over the floor, and by the time I got it all together to bring out to the recycling bin, I just had to set it to the side. They were not going in that bin. So I think they could find a way to still make it easy for us to know what's in the things, but not have so much packaging. Let me give you an example. These are 5 Q-tips in a plastic bag. Looks very cool. I don't know if I needed this little bit of waste for these Q-tips. Just stick them in this tool bag thing that you gave me, this tool case. You don't need a bag for that I'm going to throw away. I don't even know if the bag is recyclable. It might say in the instructions. If it is, I'll look, and they'll make sure they go in the recycling. So something I saw as a pro I thought was neat. Look at the packaging. Everything is all laid out. That part is great. Too much garbage, too much packaging. Okay, con number two. This might be a little bit of me, but at the same time, putting that enclosure together was not the easiest thing I've ever done. The instructions, they were not as clear as the printer instructions. If you're going to be putting together that enclosure, look ahead so you can make sure you've got the correct rails in the correct places, because there needs to be magnets at some parts and slots at some parts, and I couldn't tell from the instructions which was a slot and which one was a magnet. So I literally took that apart and put it back together 4 times. Once I realized I need to look ahead and see when they've got it together in the drawing, and see where all these magnets and things are. Once I did that, I was able to put it together. I don't know if there's an easier way to show that, like maybe highlight those more where the magnets are and the slots are. It could be just me. You might have put one of these together and been like, super easy. It wasn't for me. So maybe making the instructions for that enclosure a little easier. Now the last con is something I've heard other people complain about, is if you've got to take the plates off, the base plate, the 3D printer, the laser, or the CNC, there's a bunch of screws you have to take undone. That's the model I have. Of course, the bigger one, even more screws. It can get a little cumbersome. I'm thinking though, you're going to use one of these things for a couple of weeks, maybe a month or two even, or you're not going to be changing them out like I did, like one after the other, one day after another, which gets a little monotonous. So there's that. The other problem I was having, and again, maybe this is something I'm doing wrong, but when it came to switching out the tool heads, when it's in the enclosure, even when you slide all the doors open, the side door and the front door, it's hard to get back there and unscrew those heads. You really kind of got to lean in to get in there and see them, to see the screw. So maybe if they screwed it in the front, that would make it so that I can see them a lot easier. If you don't have an enclosure, that's not a problem. If you don't have an enclosure though, make sure you are wearing eye protection that they give you, the laser when you're using the laser, and the CNC clear ones when you're using that. All in all, those are the only cons. So let me go ahead and show you how I put this together. Again, these instructions are probably the most detailed instructions I've ever seen, and the machine went together super, super easy. Now, I was crazy impressed right when I opened this up. This is the quick start guide. It has got foil printed titles. So this thing is the nicest, on the outside at least so far, the instructions I've ever seen in my life. We'll take a look at those later. It is a thick booklet, and it is pretty, pretty neat. So we've got some, you know, foam there. Wow, this is really packed really, really nicely. So it's like, it looks like everything is, you know, sort of packed in its own boxes. So here we have a linear module rail right here. So they're all just broken out in their individual boxes, the rails. Very well labeled. Just the level of detail on how everything is packed, it all makes sense. It's stacked in here just incredibly well and labeled incredibly well. Like, here is the power module, and it is of course labeled power module. It has a line diagram of the power module. So this is pretty neat. If you weren't familiar with putting together a 3D printer or any of these things, so far pretty impressed with just the packaging involved. Tools and accessories, a nice little graphic there for that. Same thing with cables. Put that the right way. Boom. We know what's in there. What do we have here? Adapters and brackets, labeled, everything in its own box. Again, this is, they've also added that this is like a recycled sort of eco box because there's a lot of cardboard in here. This is nothing. This is just a spacer, but it's cut very well. What else do we have here? Here is sort of the meat and potatoes of everything here. We've got the 3D printer head, the CNC head, and the laser head. So really excited about that. We'll put that so it's, you know, very safe over there. What do we have here now? We've got the controller. We've got the touchscreen. Again, just crazy how well labeled everything is. Oh, wow. 3D filament, and it feels like a full roll. This is, I'm pretty sure this is going to be a full roll of filament, PLA black. That's fantastic. A lot of times people will get a new printer, and if they're not familiar at all with 3D printing, they forget to get themselves some filament. So a full roll, that's pretty incredible. I think this is last but not least. There might be one more thing in there. We've got work platforms. So we've got the work platform for the 3D printer, the CNC, and the laser, because of course each thing needs its own little work area to work on. You don't want to use the same thing you're going to use for CNC for the 3D printer. Would not work well. And I'm assuming, what do we have here? Snapmaker. The one thing that's funny, it's the one thing there's nothing on but Snapmaker. It doesn't tell me what this is on the outside, which is hilarious because they labeled the thing that said cables. So I don't really know what this is, and it is the bed for, I'm assuming, it feels like it's the bed for the for the 3D printer. So we'll see as we go. Or it might be the base. I don't know. That's really, really funny. It's the one thing they didn't label. I know what everything else is. So that is incredible. I don't think I've ever opened up a box where everything was so neatly packed and put together. So let's go ahead and actually, now that we've got all this stuff out, let's go ahead and start looking at that beautiful instruction guide and putting this guy together. Before we start putting this guy together, let's take a look at some of the stuff in these boxes, and there are quite a few of them, right? Let's look in the tools and accessories. This is what I'm talking about with how this thing is like packaged and everything. Look at this box. This thing is crazy. A smoked plastic. I mean, I'm going to keep this sucker. it's heavy, it's got a lot of weight, and why everything here has a lot of weight is all these parts are this machined aluminum with this sort of gunmetal gray, and it just looks really, really pretty. I mean, I can't even believe just the quality of some of these parts. And again, the boxes are great. So we got some box of tools, we got some little jigs there that we're gonna be putting on. This is pretty neat. Goggles. We've got some safety goggles for CNC. These are clear, and actually they're marked CNC goggles. What was I thinking? Of course they're marked CNC goggles. And then of course we got another one here marked laser goggles. So pretty good in keeping up and making sure we have all the safety items we need. So that was what is in here. If we take a look at this box of tools and whatnot, we've got our USB drive, which looks really nice, and we've got all the other pieces and parts. So we've got a ball end mill, and this is a 3.175 shank and bit for the CNC, and we've also got a flat end mill, which is again, it's a 3.71C. So we've got that stuff here. We've got little things like these are feet. So it's all our little pieces, parts, and everything is in, this is crazy. These tweezers in this, everything's individually wrapped in these smoked bags, Ziploc bags, which looks really, really sharp. The only thing that I'm super surprised at is that it actually, you know, isn't labeled tweezers. Here's another thing that really speaks to the build of this. This is the base plate, and solid aluminum. It's got a nice sort of brushed appearance to it. It's heavy, sturdy, and this is going to be our build platform. Let's take a look at pretty much the most important thing, and I've got them down here, and these are the tool heads. And if we open this up, we see the 3D printer head, okay? And this is a direct drive. It is so sleek. I mean, it is, all these things just look so cool. I mean, I just want to do like B-roll and like beauty shots of like every single piece of this because they look great. Same form factor throughout. Here's the CNC, and there's our mill end here where we put our bits onto and our collet, and then our laser. So here's our laser end. Now, the one complaint I always see is that this is a 1600 milliwatt laser. So it's not the strongest laser in the world, where most lasers are coming in at 5 watt, 10 watt. This is much, much smaller than that. One thing I did get though from Snapmaker is the 10 watt laser. So when we do the laser thing, we'll be doing it with both the smaller one, the factory one that it comes with, and the 10 watt, which I'm really, really excited about. All right, so I'm gonna get going. I'm gonna start putting this together. There'll probably be some mumbling during the process, and then we're gonna get to doing some testing. And the first thing we're gonna test is the 3D printing because, well, the name of the channel, right? 3D printed props, gotta do 3D printing first. Okay, so this is pretty neat. They give you a little screwdriver that is a really nice quality screwdriver, actually. This is pretty sweet. Oh, it's even got little carvings in it and everything. I'm assuming the bits are, yeah, oh wow, that's really nice. I'm just gonna take all these bits out, throw them across the table. This way they're out and I don't have to keep unscrewing this when I need a different piece. Okay, so step one is to put the feet on. So they come in a little bag. Flip the unit over. Screws come right in it. this is a nice little screw gun, or a little screwdriver. I might have to switch out to my electric one at some point once my hands start acting up. The one biggest pain, I would have to say, for me at least, about getting older is the fact that I have just found out that I have arthritis creeping in. And I gotta tell you, I'm not enjoying it. It's a nice little screwdriver. Okay, step one. Feet are done. So next thing we want are the linear rails, the lead 20 millimeter linear rails. So let's put these little tools away that we don't need to clear some of this workspace. And what did I just say? The lead 20 millimeters. Lead 20. Now the one interesting thing with these linear modules, these linear rails, are this metal piece right here, this silver piece, aluminum piece, that's where the motor is going to be, is behind here. And why everything is sealed and covered, which we don't have to have on a 3D printer, is the fact that this is also a CNC router, and you can't have sawdust flying in here, right? And getting everything gummed up. So everything has got to be sealed off. And this thing has just such a nice weight to it. I'm really just impressed with how beautiful this thing is. And of course, cabling here at the end. Okay, so when you got these linear rails out, you want to make sure apparently that they are aligned. So we're just going to put them next to each other and make sure that they're in the right position. They're lined up. We're talking about these guys right here. So they are aligned. Okay, so we go into the platforms box to get out this axis platform. We'll just set that aside for now. And we position this so we've got it the right way. Screw them in place. Okay, so they are on the y-axis platform. And now we're going to attach this part to the main part. And we're going to turn this over. And I'm going to leave them a little loose and then go back and tighten them up. Ooh. And even with the Aleve I took before I started this, my hands hurt. So we will probably be breaking out the little mini electric screwdriver I bought just for this occasion. I keep saying it, I cannot believe just how sturdy this thing all feels. This aluminum, just construction of everything. Very excited. Okay, so those are in there. I need to go back and tighten those. It's going together very, very quickly. I probably should have looked at that. It just said something like, make sure this is... Yeah, okay. Yeah, I got it right. Last thing I want to do is not have it right and have to take out 16 of these screws. Oof. Oh, it came right out. We're just locked in, but the fact that they provided such a handy little tool is impressive enough. Okay, those are tightened. Now we're going to put some brackets on for our Z-axis, I'm assuming. Okay, so now we got to put the touchscreen holder on, and I don't see it in this bracket area, bracket box, so I'm assuming it's in the touchscreen box. So, and it is, right here. It's got some magnets on the back, so that's what's going to hold it in place. And yes, our friends, the M48s. Okay. Wow, that's nice. Okay, so now we're going to put the Z-axis on, and these are the two lead 8mm rails, which makes sense. And here's the first one. And again, inside here, you've got all your workings, your motor, your rod. It has to be covered up because we don't want sawdust in there, right? Because this is also a CNC, something you don't really have to worry about with the 3D printer. And, oh, that's nice. Okay, so these, we need to make sure our cables, we feed our cable in and under. Nice. So it's got some built-in cable management. So that feeds in under there. Again, and super easy instruction-wise. I mean, there's only been one thing I've kind of questioned, and it was only just because it just was asking me to make sure I tighten something. But I thought, what is this asking me? Okay. Now, it seems like this is taking a while because there's so many screws and so many things. And yes, a lot of the printers I've been getting lately, they're already put together practically. So this has got a lot more sort of like construction, but it also is just a different type of machine. It isn't really fair to be saying, oh, this is just like for 3D printing. It is, but it also has to have some sort of safeguards and some, you know, be a little bit more robust for something like the CNC when you've got like a spinning, spinning bits and that type of precision. So it does have to have some really heavy-duty pieces and parts for that. All right. Now this is starting to look pretty much like a 3D printer, right? We've got most of our thing already put together here. Now, what are we doing next? Slot. And it didn't line up. And that wouldn't have been good. Wouldn't have worked. So these go on the inner ones, closest to this Z-axis. And then on this side, they go on the outer ones, outer screw holes. Okay, it says put your hands on each end of the linear rail and move it to the top axis. So we're going to move this to the top. And that is not an easy feat. There we go. Okay, so now we're gonna work on the cabling. I got a little turned around for a second because I couldn't find the cables it was talking about. I looked in the cables container and it was not the right one. And I was trying to sort of jam it in there, and I was wondering why it wasn't labeled like it is in the photo, in the book, because I had the wrong cables. The cables that you're looking for in step 17 are in the controller box. So probably should just put all the cables in one spot. Now we're, oh, that's much better. So now what this is doing is it's actually, it's a splitter. So you've got one end here that you are then gonna just sort of set here. You're gonna run the cable through the back like this, and then run it up through the bottom of here, where our rails are. And then that will go onto the controller, I'm pretty sure. And it's got, like, you know, it's labeled and everything, so that's kind of neat. Then what we do is, since this is for the Y, we connect our two Y, right? Our two Y rails, or two Y cables through here. And one goes in one, and we find the other one, and we feed that one through. I put that right on my thumb, and that snaps in there. And then we've got, boom, it's together. So both these rails are plugged into the two here, and then it comes out the other side here so that we can go, I'm assuming, into the controller box. So it's a kind of a neat way to do things. Now we're going to use one of the other splitters, and this is for the Z. So we get the Z cable, which was in the controller box. I'll look for the controller box for your cables, because that's where that was. And we'll put that in the back. There, whoops. And then both our Z cables come up through the bottom here. Let's feed the other one through. I don't know if there's a way to actually, am I recording again? Nope. I don't know. Let me go look. Because I can't tell. I am. Okay, then we just feed our Z access cables through. I'm sure there's a way to actually make these cables look a little neater on the bottom, but I guess who cares if it's on the bottom. So here's our first Z. Here's our second Z cable. And we've got our little converter box. And we plug one of the Z's into that end. This is kind of neat how they're doing this. One of these Z's on this end. We'll pull our cables through. We'll do that later to neaten it up. And then we're going to put some of these M.30s into the space. Okay, control box. And let's check to make sure there's nothing in there we need. No. So here's the control box, and yeah, really nice little rubber stoppers on everything. And again, you might think, oh, look at them, they really went, you know, over-engineered something here to put all these rubber stoppers on here. No, remember, this is also CNC, and you can't have dust and crap getting everywhere. So those were necessary. If they weren't there, then there would definitely be a problem. when you put in this controller box on, one thing I just noticed, I tightened down the screws, which I don't usually do, right off the bat up top, and then I had to loosen them again to make sure I could sort of shimmy it around a bit to make sure the screw holes lined up. So just sort of don't tighten them right off the bat, which is really, really cool. And of course our cables are marked as well, which is really, really neat. So the first 3 down here, Y and Z. So here's our Z cable, and I'm assuming, yep, we just plug that in there. Here is our Y cable, and that says Y, so we're gonna plug it in there. Why? Because we want to. And then this is our X. It isn't, this cable itself isn't labeled, but we plug that in there. Okay, so now what we need to do is we need to put the touch screen on. So I put that somewhere. Oh, it's right here. And that just looks so cool. And it pops into place here magnetically, and then our cable, USB cable, goes in, and it's a USB-C, so that's really neat. So there is a spot for it in the back, and of course everything has got rubber stoppers on it, so I'm going to pop that rubber stopper off and put that USB-C cable in. So there we go. And now we're going to be connecting to the power supply. So one of the power cables snaps in there, and I had the wrong one. And then the other power cable snaps here. Again, maybe put a lightning bolt on it so we know which one it is. Although I think it's the same one, I just got it wrong. Here is... Okay, so that's the base machine. Very simple to put together. The instructions were incredible. I can't think of anything wrong with any of the instructions and how I've got to put this thing together. Anything that was a mistake, I literally didn't read it, or I didn't look at the pictures carefully enough. And they are very, very clear, so I was really screwing up. Very, very cool. Now, the next thing what we're going to do is we're going to jump to the beginning, if you haven't watched that yet, and we're going to actually start adding on the modules, because now this is the base unit. And now we go ahead and we put on different work platforms that are in this box here. We put on the different heads here to do the different things. So the first thing we're going to do is do some 3D printing, and we're going to do some laser, then some CNC. This all has chapters, so if you want to jump around, go ahead and do that. But yeah, really, really happy with the build quality of this. So let's get going and putting together the things we need to have added to do a 3D print. But I've been really, really happy with this, printer. It has definitely surprised me. I thought that the 3D printer is going to suck, but the laser and the CNC are going to be great, or one of them is going to be a lot weaker than the other. But they all performed well. Last thing I would say is you might see some videos out there where people are saying this part of it's crap or this part of it doesn't work well. When I watched those videos, the thing I was struck with was they were great videos, don't get me wrong. These guys are great who do lasers and CNC and things like that. They were comparing them against this machine, against a $10,000 CNC machine they have, using light burn and everything. That's not what this is, right? So you gotta look at videos like this, look at videos where people aren't like super comparing them to like these super machines, these $10,000, $15,000 machines, to see if it's gonna work for you. And if it is, look at picking one up. If not, just pick up a 3D printer. They're fun, I like them. That's it, guys. This has been a long one. Thank you for watching. I hope you enjoyed it. I know I did. And I'm gonna start cutting up some more Batman bat symbols. Why? I don't know, but I can, so I'm going to. All right, guys, take it easy. If you liked the video, click like, subscribe, and I will see you in the next one.